Hi YouTube, this is Mike, and this is part 5 in a series on coding Ultimate Texas Hold'em in C++. And in this video we're going to be looking at the decision of whether to make the large raise or not before the flop. And at this point there are a lot of things that could possibly happen according to how all the rest of the cards fall. It has to do with the hand the player gets, whether the player, what kind of raise the player makes, whether or not the dealer qualifies, and who has the higher hand. So if the player checks the large raise, I'm up to 45 different possible events of the way things could happen according to whether the player makes the medium or the small raise, what hand he gets, whether or not the dealer qualifies, and so on. And it matters what type of hand the player gets because of the blind bet. The better the hand, the more that pays. So here I have numbered 0 to 44 different possible events and what each of them pays. These columns here show what the ante-raise and the blind pays, and column H here shows the total win. And down here I have concatenated with the concat function all of these wins so I can more easily keep track of everything. And I'm going to copy and paste this list of wins over into C++. And here's all the ways things can happen if the player makes the big raise. Again, it matters whether or not the dealer qualifies, the hand the player gets, and who wins. So notice the raise column here is now at 4. If the player loses, he loses 6 units. And here is what the player wins according to all those different criteria. So I'm going to copy and paste this list of wins over into C++. So here we are back at our our program, and we are going to write another function to evaluate the large raise decision. And I'm going to call it flop because the way I've been titling functions is what is the next thing to happen after the decision is made. And in this case, the dealer will deal the flop, which is 3 community cards. So, and the structure of this is going to be much like the turn function. So what we're going to pass to this is the player's 2 cards, his 2 whole cards, and I am going to pass back an array. One is going to be called the check event, and one is going to be called the raise event. And I did it just the same way in the turn function. So one array is going to hold all the combinations of the ways things can happen if the player checks, and the other one if the player raises. And first let's, the program is going to need to know how much the player wins with any given event. And I already calculated those numbers in Excel. And I just need to go to Excel and copy and paste them into C++. So here are those check wins. And here are those raise wins. So let's initialize those arrays. So let me remind myself, there are 0 to 44, there's 45 ways the hand could play out if the player checks, and 22 ways if the player raises. Okay, I think we're ready to start looping now. So we're going to decide what three community cards are. We'll call them C1, whoops, I didn't need to say int, C1, C2, and C3 for the first three community cards. And what am I doing? This should be C1. So we're going to cycle from C1 equals to 0 up to 49. And now let's check that that card is in the deck. And you may recall from the other videos that I have this array called deck. And if the value of that card in the deck array is equal to 1, that means that it is indeed in the deck. So now let's take it out of the deck. And the very next line, I'm going to put it back in the deck, because I have been known to forget to do that before. So now let's get in between those lines and look at the next card in the flop, C2. So that can range from C1 plus 1 up to 50. So now let's see if that card is in the deck. And if it is, let's take it out. And then put it back in after we're done with whatever we do. And then again, get in between those two statements. And now let's look at C3. So that can range from C2 plus 1 up to 51. And now let's see if that is in the deck. Always remember the two equals. If you put just one, you're going to really screw things up, and it'll be really difficult to find that error. Now let's take it out and put it back in. And now we're ready to write some code where we pass this information onto the turn function. We are now ready to call the turn function, which we wrote in part 4 of this video series. And we are going to pass to it the player's two hole cards, which are called P1 and P2, those three community cards, which we just determined, and I need to give this a different name. We need to pass to it arrays for what could happen with if the player checks or raises after the medium raise. So let's think of names for those. Let's call them the check, medium, raise array, and the ray and the no, let's excuse me, yeah, check, we'll call it the check medium array and the raise medium array. The medium meaning the medium raise after the flop. And let's declare those. And let me remind myself how big those were. Those got up to a size of 22, so they So they have 23 elements in them each. All right, you may recall that back in the turn function, we return a value of 1 if the player makes the medium raise and a 0 if he checks. So let's make a variable for that. Let's call it just medium raise. Whoops, I put that in the wrong function. Let's take that out here, and it belongs in our flop function. So if the medium raise is a 0, that means that the player checked with those cards after the flop. So if that happens, then let's increment the check event array by all the things that could happen if the player checks on the medium raise. So there are 23 possible events. Otherwise, the player did make the medium raise after the flop. However, we're still adding it to the check event array because this means that what happens if we're checking on the large raise. And I know this is kind of confusing. Okay, and here with the check event array, we start numbering our medium raise events with number 23. So I'm going to add 23 right here. And here we only number up to 21. Because the player never folds after the flop. Next, let's increment the raise array, and that goes up to 21. By and I realize this naming might be kind of confusing, but what's going to go into this array is all the things that can happen if the player makes the big raise before the flop. So there can be no folding. And you will see why I'm doing this in just a minute. So after we get done with all this looping, we can calculate the expected value of both checking and raising. So we'll call those the check EV and the raise EV. And let's initialize both of those to 0. And next, for the check EV, again, there are 45 possible outcomes of the way of what can possibly happen. So that goes from 0 to 44. So first let's multiply by the win, and you may recall we called that the check win. And then by the number of times each event can happen. Whoops, I spelled that wrong. And now, let's just write similar code for the raise expected value. So with the raise, it only goes up to 21. So for now, let's output the expected value both ways. And let's just copy and paste that line for the raise expected value. And I believe I did this in the flop, but I'm going to comment that out because I don't need to see that hundreds of times for all the ways the flop could happen. Okay, one more. So at this point in the program, it's going to start to take a while to do anything, and I'm going to want to know how much time. So I'm going to declare a variable called cur time, which will stand for the time at this moment. So let's okay, and the way you get the time is with this time function. And this is how you do it. You just call time and send it over nothing. And I believe that I'm going to need to put this include statement at the beginning of the program. So it will know what to do when I call that function. Okay, where was I? Flop. Okay. Another thing I want to do is I think I'm going to, whoops, I'm going to just state, no, let's do it here, just to make sure that it's running properly. I'm going to output C1 and C2, just so I'm not getting just a blank screen for hours. Okay. Time in the wrong function. Yes, I did. I put it in turn when it should be in flop. And then I'm going to do that again at the end of the function. And by the way, it's going to print out like the number of seconds since some arbitrary date in time. And subtracting one from the other, I will be able to figure out how many seconds the whole program took. And as long as I did that, I'm curious to see how long. Let me go to score 7 all. When it scores the hands, this takes, I don't know, roughly 30 seconds or so, but I'm curious to know exactly how much time. So I'm going to do it at the beginning and the end. Now let me put it at the very end here. Okay. And let's go back to the flop function and declare it. Okay, in compiling this, I'm trying to compile it. It told me that I never used this dealer event array in the turn function, so I should have fixed that error in the previous video. You recall that I now call the array dealer event when it gets passed to the dealer, but I don't want to get back into that. And it also said that I declared cur time twice, which is true. So yeah, so I don't need to say what kind of variable I don't need to redeclare it. Okay, so also you can see that I declared this function flop as an integer, and much like the turn function, I'm going to pass back, if the raise expected value is greater or equal to the check expected value, then I'm going to pass back a 1, otherwise I'm going to pass back a 0. And you'll see what we do with that in the next video. Okay, YouTube, we're finally ready to put this all together and analyze the whole game. So let's create a function to do that. For lack of a better idea, let's call it entire game. And let's see, where shall we start? We're going to need to have a variable for how much each event pays. So we'll call that UTH-pay. And let's go over to Excel to get those events. You may recall it in an earlier video, I labeled all the possible events here and showed how much the ante, raise, and blind all win and add them all up. So to make a long story short, this sequence of numbers is an array for what? All, I think, 69 or 70 possible events pay. Okay, what shall we do next? We need to, well, let's start with the pairs. And let's declare two integers, rank 1 and rank 2. Well, let's just declare rank. Yeah, let's go ahead and declare both of them now. So to pairs, let's go for rank 1 equals 1. Rank 1 goes up to 12. I'm sorry, rank 1 should start at 0 and go up one at a time. And first, let's remove those 2 cards for whatever the rank is from the deck. So we're going to remove 4 times, let's use a parenthesis just to make it look good. 4 times rank 1. So we're going to remove that card from the deck. And then let's just add 1 to it for another card of the same rank but a different suit. So here we are removing those cards from the deck. And then after we execute some code, we're going to add them back in. So we're going to be calling flop. So you might recall that flop will return a 1 if the player should raise and a 0 if he shouldn't. So let's declare a variable, call it raise on flop. To be whatever comes back from flop. So we need to send flop some things. First of all, we're going to send it 4 times rank 1 for one of the cards, and 4 times rank 1 plus 1 for the rank of another card. And then we pass to it, you may recall right here, 2 arrays. One is going to fill with all the kinds of events that can happen if the player checks, and the other if he raises. So let's declare those in this function for the entire game. And we need to declare big 64-bit integers for these. So you may recall the check event gets as high as event 46, so we need to declare an array of size 47 to include element number 0. And also raise event, that can go as high as event 23, so we need to declare something of size 24. And for the whole game, we'll call that UTH event for Ultimate Texas Hold'em. So that goes as high as 69, so we need to declare an array of size 70. So before we forget, let's also declare I to do our initializing. So for I equals 0, and we run up to 69. So we're going to initialize the UTH event array to be 0. And let's see if we initialize the arrays in flop. It looks like we don't, so we're going to have to do it here. So here we're initializing the check event array that gets sent over to flop. And let's do the same thing for the raise event array, which can go up to element number 69. Okay, so let's send over those arrays to get filled up in flop. Okay, so as I mentioned, if raise on flop is a 0, which as a reminder, is what flop, the flop function. Remember down here, if the raise has a greater expected value, it returns a 1, otherwise a 0. So if we get back a 0, the player checks the big raise. So what we're going to do there is fill up the UTH event array with the stuff that's in the check event array. And add it to the UTH event. And we need to apply some kind of a weighting factor. So there's 6 ways you can pick 2 cards out of 4 suits for this pair. So I'm going to multiply everything that comes back from flop by 6 when we're dealing with pairs. And now let's write some code if the player raises. So let's just copy and paste those 2 lines. And the raise event goes as high as element number, let me have a look at flop here. As high as element number 22. And I guess raise event here only needed to go as high as 23. And this should, this only needs to go as high as 22. Okay, and so here, this is the code for raising. Let's call this just make big raise, so we don't use the word raise twice. And here we're going to add to the UTH array the stuff that's in the raise event array. All right, so that will take care of the pairs. So next, I'm going to copy and paste that code, and let's deal with the suited singletons. So the player has 2 different ranks and they're suited. So here we need to add a loop for the second rank. So that will start with 1 more than the first rank and go as high as 12. And 1 at a time. Let's indent all of this. And rank 1 only needs to go as high as 11. So these 2 loops here will take us through all the way you can choose 2 ranks out of 13. Okay, what do we need to remove from the deck? We need to remove 4 times rank 1, that's fine, and then 4 times rank 2. And let's take out this +1 because the cards are suited. And let's add them back in down here. So how many ways, and let's make sure we pass over the right cards. So here we're passing over 4 times rank 2 and taking out this +1 again. And there's 4 possible suits, so we're going to change this weighting factor from a 6 to a 4. And finally, let's analyze the unsuited singletons. So here I copied and pasted the suited singleton code, and all we need to do is add 1 to the second rank to make it a different suit. I want to put in some parentheses here just to look neat. And how many ways can you choose the suits if they're unsuited? Well, the lower one, for example, can be one of 4, and the higher one can be one of 3 that's left. So the weighting factor here is going to be 12. And what I'm going to do after every single calculation is I want to print out the results. And why don't I just do that at the end? It's because Windows has a really annoying feature, I shouldn't say feature, a really annoying way of sometimes rebooting in the middle of the night and you lose whatever you're running. Okay. So after these calculations, what I'm going to do is print out the results, print out what's in the UTH event array up to this point. So again, that can go as high as element 69. And you might say, why am I using the printf function? I found that when you're printing stuff to a file, it's just more dependable than the cout function. I've had problems when you print out just a lot of stuff that when you use cout, it sometimes gives you stuff in the wrong order. And printf is just much more dependable. So first I'll print out I. And then I think I'll print out the UTH pay, what the event pays. And \t, by the way, is a tab. And then I'm going to print out what's in UTH event array. In other words, the number of combinations. So here's I, UTH pay. And by the way, I don't really need this UTH pay array in the program. I've just put it in there so I can export it with the output. It's not directly used. And then UTH event. Whoops, it's not Utah event, it's UTH event. And let's copy and paste this code to the suited singletons and the unsuited singletons. And this program is going to take a small number of days to run, maybe like 4 or 5. So I'd like to, just out of curiosity, I'd like to get like an exact count. So I'm going to declare a time variable. One I'm going to call start time, and now the other one I'll call current time. So start time, I'm going to put in the computer time at that exact moment. And let's export that. Let's just use a printf. I think I can use a %i for that, for a time. No, I'm not sure. Let's just do a cout. And then when this is all done, let's get another time. Except this time it's the current time. There's 1 R in current. let's also print out total time. Call that total seconds. So it's going to be current time minus start time. And let's declare this whole function. Put it right at the beginning. Let's go to our main, and we're going to call it. So, wow. I think the only thing left to do is to run this program. Hard to believe. But just to be on the cautious side, like I said, this is going to take a long time to run. I'm going to comment out for now the suited and the unsuited singletons. And so it's only going to run the pairs. And I'm going to look at those results to make sure that they look good before I proceed with the rest of the program. So I will be back after I run this code. I knew something didn't feel right. So if the player makes the big raise, then the UTH event, the elements starting with 47 are for making the big raise. So I need to add a 47 here and here and here. That will populate the array for the whole game results, whoops, in the proper place. Okay, now I think we're ready to run this. So it's 6.5 hours later, and the results for the pairs look reasonable. I don't know if they're exactly right, but they pass the smell test. So next, let's do the unsuited pairs. So let's comment out, the pairs, and I meant we're going to look at the suited singletons. In other words, two cards of different ranks, but the same suit. And we'll go back and comment out the unsuited singletons. And one thing I want to do to just see the progress as it's going, because this is going to take over a day to run, is I'm going to just output rank 1 and rank 2. And I think I will do that to both the screen and the file. So a CAir and a Cout. And I'm going to put that same code for the suited singletons. Okay, let's compile this. And compiled, so I'm going to run it and get back to you when it's done. Okay, I'm back. It's 39 hours later, and the suited hands finally finished running, and I am ready. And I spot checked some of the hands, and they looked reasonable. So I'm ready to start on the unsuited hands. So let's comment out the suited code. And uncomment the unsuited code. And I'll get back to you when it's done. I am back, and the third part of the program finished running, and what you see before you is Excel, and this is a summary of all the results. In column A, we have what hand the player got. In column B, we have what type of raise was made, if any. Column C shows whether or not the dealer qualified. Column D shows the overall win or loss, if it's negative. And you may recall
that all these numbers are in an array that the program used. So here are the combinations if, let me move this box, if the starting hand was a pair. Column F is if the two player cards were suited. Column G is if they were unsuited but not a pair. And column H is the total number of combinations for all situations. So down here in cell H72 we have the total combinations, and let's just calculate that manually just to see if it's right. So there are the number of ways you can choose 2 cards out of 52 is the Excel function is combin 52, 2 times combin 50, 3 for the flop times combin 47, 2 for the turn in the river times combin 45, 2 for the 2 dealer cards. And let's take that out of scientific notation. And there you can see that the 2 numbers match. And column I is the probability of all 70 possible situations. And column J is the product of the probability and column D, or what that event pays. So, big final answer after all this work is cell J72 here. It shows the player can expect by the end of the hand, with perfect play, to lose 2.185% of 1 unit. So there you go. That is what I would call the house advantage. And however, I have to give a little talk about the element of risk. If you want to compare any game against another game, I think you should look at the expected loss compared to everything that you bet. So, as you know, in Ultimate Texas Hold'em, there's an ante and a raise, and usually a raise bet. So I took the liberty of adding up the probabilities of a small, medium, and large raise, as well as a fold. A small raise is about 21.8%, medium raise 21.3%, large 37.7%, and folding is 19.2%. Here's the total bet, and here is the expected bet, which is the total bet times the probability. And cell E80 gives us that by the end of the hand, the average wager is 4.15221 units. So if we divide the expected loss of 0.02185 units divided by the expected bet, we show that the element of risk, in other words, the percentage of all the money that the player bets that he can expect to lose, is 0.53%, which is a very good value. And it's also very surprising considering this game is fairly new. Came out, I don't know, about 10 years ago. So, and the reason it does well for the casinos is tons of player errors. And I played this game a lot, and players simply do not know the strategy. They fly by the seat of their pants, and I'm sure that the players lose way more money than this on a percentage basis. So, wow, there you go. That is the end. I can't believe it. I have been working on this project for a long time, and I still need to upload it, but edit and upload the videos, but that's done actually with the video making of it. And I will try to put in the video description a link to the actual code. YouTube may ding me for that, but I really want you to have it. So there we go. That is the end. Thank you for watching, and I have a lot of other videos where I show you how to code other casino games. This is by far the most longest of that category video. But let me shut up. Let me say goodbye, and have a good day. Thanks for watching.